Okay. So good morning, everyone. I hope everyone is doing okay, even though it's still pretty early. Uh, my name is Tomaz Muraus, and today I'm gonna present the Luvit and Virgo project. I know you're probably thinking, what the hell is that? Because both of the projects have kind of a cryptic name, but I'll dive in soon, and you'll soon find out. So here's the agenda. And who am I? I'm Tomaz Muraus. I work at Rackspace. I used to work on cloud monitoring, which is a REST-based, fully distributed monitoring system. And currently I work on Service Registry, which is a REST-based API for registering your services and your processes. I'm also a project chair of a Apache Deep Cloud project, which is a project which deals with working with different cloud APIs and also like open source and open standards. So what is Luvit? Luvit is a framework or a platform for building different network applications written in Lua. Luvit exposes Node.js API, but on top of Lua. I don't know how familiar you are with the Node.js, but Node.js is basically server-side JavaScript. Basically, you can write your networking applications in JavaScript, and Luvit aims to do the same thing, but instead of writing your apps in JavaScript, you can do it in Lua. So Luvit stands, Luvit name is composed of 3 words. First letter is L, which stands for Lua, which is the language you write your apps in. Second abbreviation is UV, which stands for the libuv. Libuv is the actual C library, which deals with the cross-platform and the event loop stuff, which is also used by Node.js. That's one of the biggest users and also used by Luvit. And the third part stands for Luajit, which is a just-in-time compiler for Lua. So Luvit is a open source project licensed under Apache 2.0. So here's a quick example to get you excited. If you're familiar with Node, you can probably already see what the example does, but basically it starts an HTTP server, and when you hit it, you get a back response which says, "Welcome to Fosdem." So the code in JavaScript would actually look pretty similar. There's some syntactic differences because Lua doesn't have object, but it has like tables and meta tables, and there's some minor differences there, but otherwise the API is pretty similar. So some history, Luvit project was originally developed by Tim Caswell. Tim Caswell is a pretty cool guy. You should probably go check out his GitHub page and follow him there because he has a bunch of cool and crazy projects. I think at the moment he's working on his own language, so basically he has a bunch of cool stuff. But Luvit is a pretty young project. First version was released in 2011, and soon after the first version was released, my team at Rackspace decided to help with the project because basically we decided to use it for our monitoring agent, which I'll describe more later. So yeah, like the slide says, we contributed a lot to the project, and we're still contributing. So if nothing else, there are also a bunch of other independent contributors, but there are also a couple of paid people working on it. So yeah, why should you care? First thing, I guess, is Lua is cool. I personally like Lua more than JavaScript, although it does have some bad parts which are similar to JavaScript. For example, JavaScript doesn't have a 64-bit integers. It has this messy number type, which makes a lot of things difficult, and there's pretty much the same problem in Lua, but in Lua you have other things such as coroutines and other stuff. So Lua was primarily developed by, I think, some academics from Brazilian university, and it's used a lot as a secondary / scripting language in different apps and games and so on. I guess a couple of popular uses are World of Warcraft game, where I think the graphical interface and AI is built in Lua, and FSM which is a tiling window manager. And one of the strong points, I guess, or one of the Many reasons Lua exists is because it's easy to embed it. It provides a simple C-based stack API, which means you push a value on a stack and you can pop it off, and that's basically how you integrate with other languages. So here's an example of the C-based stack API. As you can see, you push an integer on a stack and you push the integers, and then you call the function you previously saved the reference to, and you get a result back. So it's pretty easy to embed it. So what is Virgo? Virgo is a monitoring agent we built at Rackspace for running on many different servers. So when we decided to build the agent, we had some requirements in mind, and one of the requirements was, I guess, decent performance and low memory footprint, because this agent is going to run on your server pretty much all the time, and you probably don't want this agent to affect other services like web server or whatever running on your server. So that's why we decided to go with Luvit. So yeah, basically Virgo is not just a Rackspace cloud monitoring agent, but it's a platform for building other host agents. Host agents is basically pretty much any kind of long-running process which performs some kind of action on host operating system. In our case, this is collecting metrics and sending them back to our endpoint, but you could also use it, for example, to execute commands on your system and so on. So yeah, why did we pick Luvit? One of the goals was, as previously mentioned, was low memory footprint, and we basically wanted to speed up the development cycle. If the agent would be written in C, this would probably get even lower memory usage, but this means we need to deal with manual garbage collection and so on, and it will also, the whole development cycle would be pretty slow. So we basically have a core which pretty much bootstraps the process which is written in C, and the core is pretty much responsible for handling the option parsing and logging, but the rest of the stuff is outsourced to the Luvit layer. So pretty much all of the business logic is written in Lua, which allows us to also, besides the faster development cycle, it also allows us to basically, if we want to ship the update, we can just ship the updated Lua code, and we don't need to restart the whole process. We can just reload the Lua code, and without restarting the whole process, we can reload the business logic. That's stuff I previously already mentioned, and one of the things I also wanted to add is we also wanted to make it really secure, because there are a bunch of other monitoring agents written in Ruby, Python, and so on, and some of those agents don't even use HTTPS or a secure connection. So our goal was to only use a secure connection on all the bundles. Bundle is basically a tar package which contains a Lua code is signed, and also the binaries are signed. The actual signing depends on the platform. We use the Debian specific stuff on Debian systems, and on Windows we also use the Microsoft thing for signing the executables. So we pretty much made it really secure. Another thing we wanted to do when we build the agent is keep the protocol simple. So we decided to go with a new line delimited JSON. Here's an example of the outgoing message. In this case, we send a heartbeat, which is kind of like a ping. So we have this semi-structured JSON. Some of the fields like ID and version and so on are required, and other stuff like params are optional and depend on the actual method. And here's the response from the server, for example. Here's a graph which shows memory usage of agents written in different programming languages. There's an agent written in C++, Ruby, and so on, and there's our Virgo, which only uses around like 5 megabytes of memory. We could actually go even lower, but because of, we also wanted to make the whole agent really cross-platform and portable, so we decided to statically link all the libraries, which does increase memory usage a bit, especially because we link against libopenssl, which is known to take a lot of memory. And here's a quick diagram of our endpoint architecture. Basically, agent connects to multiple endpoints. That's for high availability reasons. So if one of our data centers goes down, for example, your agent can still send metrics to us, and we can process them and send an alert, for example. Basically, agent establishes 3 persistent long-running connections, but it actually only sends data, which is metrics and other system information, over one connection. And if this connection dies, other secondary connection is promoted to a primary connection. So I guess that's it. I hope I got you interested. And if you have a similar problem, for example, if you want to embed something or you need a low memory footprint and fast execution, you should probably check Luvit and Virgo. And I also want to add that, yeah, if you're interested in this kind of problems, my company, Rackspace, is looking for new people to join us. So let me know, go to this website or send me an email or find me around this room after the talk, I guess. Thank you. Oh yeah, and also have some Apache libcloud, Rackspace Cloud Monitoring, and Rackspace Service Registry stickers. I'll leave them on the desk, and you can go grab it.